Well, hello guys. Before you get into the next lesson, I just want to clarify some things from our last one, just to make sure you understand completely. When you are identifying scientific notation numbers, we need to make sure of two things. Well, of course the x's, the times has to be there, but we're looking at the first digit that's in front of the times, the first factor, and we're looking at the second factor. And there are two things we need to decide of those things. In the first digit, I said you have to be at least a 1 but less than a 10. To figure that out, what I want you to think of too is look in front of the decimal point. Look in front of the decimal point. You should have one digit and one digit only. And that digit cannot be 0. All right? So if you look in front of the decimal point and you see more than one digit, then you know it's not scientific notation. If you look in front of that decimal point and you see a 0, it is not scientific notation. So look at that decimal point and then look in front of it. If the number in front is anything except 0 or 2 digits, then you know that at least the first half of our question, or first half of our number is in scientific notation form. So we have that part correctly. The second thing we need to decide is it base 10 raised to a power? Doesn't matter if it's negative or not. Doesn't matter how big or how small this negative or positive exponent is. Just that the 10 is raised to a power. So, let me say that again. The first factor has to be one digit in front of the decimal point, but not 0. So these are all good. 1.3, 1.0, 5.8989 or whatever, or even 9.99999, those are all good first factors in a number that's we're trying to figure out if it's scientific notation or not. These are not any good down here. This has a 0 out front. I don't care what this says. That's a 0. I can't use it as scientific notation. Same with this one. Even though 0.99999 is very close to 1, it still isn't 1. The digit out in front is a 0. It is not 1, 2, 3, 4, 5, 6, 7, 8, or 9. Now for the other two, of course, 10 is too big down here. Remember, has to be less than 10. And it's got 2 digits in front of it. This has 2 digits in front of it. It has, anyway, it's that simple. It can only have 1 digit in front of the decimal point, and it cannot be the digit 0. One more thing I want to point out is how to know when you're looking at two numbers written in scientific notation, how do you know which one's bigger? Well, I mentioned in the last lesson that the negative sign on the exponent means that it's a really small number. So basically all you're doing is most of the time you're just going to compare the two exponents. Which number is bigger? Is negative 32 a bigger number than 9? Well, if you think about your number line, where is the negative 32? It's way off to the left of a 0. It's way smaller than a 9. Okay? So that makes this is the bigger number. We don't necessarily go by these two unless my exponents match. If they were the same exponent, if they were both, let's say both of these were negative 32, then 4.9 is bigger than 1.34. But since the exponent is different, then we look at that and choose. But if they were the same, we would then look at these. But you start with the exponents. So this is the bigger number, and it doesn't matter that the 1.34 is actually smaller if we compare it directly to a 4.9. Okay? What matters is the exponent. Okay? Now on with your regularly scheduled lesson.